Hey guys, this is Abhishek and today we'll be learning about TensorFlow, an API used for large-scale machine learning on heterogeneous distributed systems. What is TensorFlow? It's an open source software library for numerical computation using data flow graphs. It can also be defined as an interface for expressing machine learning algorithms and an implementation for executing such machine learning algorithms. It is developed by researchers and engineers working at Google. It's an extension to an already existing machine learning API called DiskBelief, built by Google itself previously. The nodes in the graph represent mathematical operations. Similarly, the graph edges represent the tensors, or also called n-dimensional or multi-dimensional data arrays, which communicate between these nodes. It covers hundreds of products at Google. Why machine learning? Image recognition, speech-to-text, web search, image captioning, and robotics are few use cases of machine learning. Image recognition is classifying image into certain class based on certain characteristics. Speech-to-text forms an integral part of the latest handheld devices, wherein a person speaks in his or her particular language, certain language, and gets back the output as a text. Web search engines such as Google and Yahoo need to rank the pages in order of relevance. It is called ranking, and this uses machine learning extensively. Image captioning is describing an image by retrieving certain characteristics. Robotics uses a lot of machine learning, as the autonomous robots need to take certain decisions, and these decisions need to be trained beforehand so that the decisions taken by the robots are right and precise. We need not worry much about the details of what is bias addition and rectified linear as of now. The only thing that we need to take away from this particular slide is that the nodes represent operations and the edges represent tensors. Moving on, computation as a data flow graph. It's a simpler version of the previous example that we already saw. These represent weights, biases, and these are again the operations. It is as it's already written here, graph of nodes also called as operational ops. So what exactly happens in this case is these are the inputs will be fed here, the weights and the inputs and the biases will be fed at a later level. So matrix multiplication happens here, the output in the form of tensor, like these tensors are nothing but the data which carry data into the add operation, which acts like an input to the add operation and along with the bias. So add will not execute until and unless it's got its input from bias and it's got its input from matrix multiplication. Here we can observe that this matrix multiplication operation is the output of the matrix multiplication operation is nowhere connected or is independent from the input of the bias. So this input to both the inputs to the add operation can be run in parallel. The essence of this is they can be run on different CPUs, they can be run on different GPUs or entirely on different machines. This example illustrates it in a better manner. So basically it can be distributed across threads, processors, GPUs, machines, and also many operations can be executed in parallel. Here bias, the learning rate are currently executed on device B, but the add operation which gets its input from bias and assume it to be another input that goes into add. So this is running on device A, and all these the output again we can observe that the input for multiplication operation is also coming from learning rate that is currently running on device B. Similarly, multiple devices it can be deployed. An application, if it is independent, can be deployed across multiple devices and also multiple CPUs or GPUs. So we can also observe that again the output goes back into the goes on to run on device B. Now we see the features of TensorFlow. Deep flexibility through portability connects research and production. Auto differentiation, maximizing performance and language options are two features of TensorFlow. Deep flexibility. TensorFlow isn't a rigid neural networks library. If you can express your computation as a data flow graph, you can use TensorFlow. Moving on to true portability, TensorFlow runs on CPUs, GPUs, desktop, server, or mobile computing platform. If you want to play around with the machine learning idea on the laptop without needing special hardware, then TensorFlow is just for you. If you want to containerize with Docker, and TensorFlow just works fine. Okay, connection between research and production. Gone are those days when moving a machine learning idea from research to product required a major rewrite. Now it is faster using TensorFlow to train and serve models live to real customers. Using TensorFlow allows industrial researchers to push ideas to products faster and allows academic researchers to share code more directly and with greater scientific reproducibility. Moving on to auto differentiation. When we use gradient-based machine learning algorithms, it will be benefited by TensorFlow's automatic differentiation capabilities. As a TensorFlow user, we can define the computational architecture of the predictive model, combine that with the objective function, and just add data to it. And everything just works fine because TensorFlow handles that computing the derivatives for you. Computing the derivative of some values with respect to other values in the model just extends your graph so you can always see exactly what's happening. Then maximizing performance, if you want to use all the cores effectively, like for example you have a 32 CPU cores and 4 GPU cards, and with first class support for threads and queues and asynchronous computation, TensorFlow allows you to make most of your available hardware, and you can only freely assign compute elements of your TensorFlow graph to different devices, and the TensorFlow will handle all the copies instead of the user, or for the user. Moving on to language options, TensorFlow comes with an easy to use Python interface and an easy to use C++ interface. To build and execute the computation graphs, you can write standalone TensorFlow models, and Python or C++ programs can also be written in the Python program can be written in the TensorFlow IPython notebook, and where all the visualizations and can be logically grouped, and continuous efforts are being made to give more language options such as Java, Go, Lua, JavaScript, or R. Hey guys, and let's see how we go about downloading and installing TensorFlow on Linux. So, this is the TensorFlow.org, that is the official TensorFlow website, and let's have a look at the basic requirements for you to install TensorFlow. It requires Python 2.7 and 3.3 and above versions, and this is optional. You might or might not have a CUDA or NVIDIA graphics card installed on your machine. You can actually check that using this command. Yeah, you can see that it does not, OpenGL vendor string does not say NVIDIA. If it says Intel, that means you have an Intel graphics card on your machine, or if you have NVIDIA here, NVIDIA Corporation here, that means you have NVIDIA graphics card installed on your machine. Only if you want to make use of GPU, that is only possible if you have NVIDIA graphics card in your machine. Since I don't have it, and since it's optional and you can run it only on CPU, let me do it on the CPU itself, run it on the CPU and install it on the CPU itself. Okay, there are different methods to install TensorFlow. Again, pip install, virtualenv install, Anaconda install, and Docker install. Pip install if you want to make changes to your existing Python packages or Python programs. You can do pip install, because in case you need to update, you have an older version, this directly affects your Python packages. Virtualenv it installs the packages in its own directory, so hence it does not affect any existing Python programs. And Anaconda install, it has an environment on its own, and it too, like virtualenv, it also does not impact any existing Python programs on your machine. Docker install. Docker is basically a virtual environment or a virtual machine, so it runs in an isolated space, and it would not again it would not affect any other programs on your machine. Not only Python, see this says from all the other programs. Machine people who would like to run in an isolated space can go for Docker, but as of now I'll be going for pip install. Yeah, so let's see. Yeah, so mine is a 64-bit version of Linux. So let's see how to go about installing this. Just copy paste this. Password. Says reading package lists. So since I already have that TensorFlow install machine, it says 0 upgraded, 0 newly installed, and 0 to remove, and 25 not upgraded. And people who are working on Mac can use this command. Okay, how we go about installing TensorFlow, and this is for the CPU and it is for GPU. Since I don't have an NVIDIA graphics card and I run only Intel graphics card HD 4000, so I'll be going for the CPU only command. So let's see. It's downloading, it will take some time. So yeah, this is for the Mac, and yeah, this is for the GPU. Okay, so and this is for my Python 2.7 version. I mean, it's for Python 3 you would be doing this. Since I have Python, I have both the Python versions, but I am showing this particular demo for Python 2.7. If you have Python 3, you could do this for Python 3 plus versions. And this is how we go about installing virtual env, installing TensorFlow to virtual env. And similarly, this is how you go about. All the documentation is very precisely and neatly given in the tensorflow.org website. For more information on installing and downloading a TensorFlow, you could just look up there. And this is about Docker installation. Yeah, so this says that it's optional that you enable GPU support. So I just skip this part. And let's see whether it's downloaded or not. It might take some time, and we'll just come back once it's done setting up. Yeah, it looks like TensorFlow is installed. It says successfully installed TensorFlow NumPy. Yeah, so just let's just check whether it's been correctly installed. Run your Python library. Just 2.7 version. We just say import TensorFlow TF. This runs correctly, that means it's installed. Take some time. Yeah, here you go. Okay, so you can also run other programs on this. So for example, something like we just do this. And you create a session here. We'll talk about this in a more elaborate way in a later part when we take up a real world example. This is just to check whether it's running properly or not. Yeah, so let's also just type this, check whether it's running, which you're just trying to create a constant in this case, and you just say print the session dot run. If you have to run anything, nothing will be done until and unless you actually create a session and run something. So got that? So we're done with the installation process. Now we move on to a real world example. What will we learn in machine learning? There are basically 4 steps of machine learning. The first one will be creating a model. The second one will be defining cost function for that model. The third one will be collecting data. And the fourth one will be training data. These 4 steps of machine learning can be compiled into 2 parts of TensorFlow. The first one will be model linear regression and cost function as TensorFlow graph. The second one will be train TensorFlow graph with the data set. What is the purpose behind machine learning here? We need to predict something given a set of features that influences prediction. In our problem, or in this case, the features are the house location, house size, and house configuration. If the house is located in a very posh area, the size What is the purpose behind machine learning? Predict something given a set of features that influences prediction. In this case, in our problem statement, the features are house location, house size, and house configuration. If the house is located in a very posh area, definitely the price is much higher when compared to the same size of the house at a normal place. Definitely the configuration, if it is fully furnished or it is just the apartment which you get or just an independent house, even the size, depending on the size, the price also varies accordingly. Okay, so now let us see this. The x-axis will be the house size in square meters and the house price is in dollar along the y-axis, and the plots, we already have some data plotted, the points plotted on the graph, which says that for 10 square meters this is the price, and the 20 square meters this will be the price, 30 will be this, 50 will be this, and for 60 square meters will be corresponding to such and such a price, and etc. But in case if you want to predict the price, the cost of the house for 40 square meter, how would we go about it? Yes, you are right. By just drawing a straight line such that the line is best fit for all the points. So this is nothing but linear regression best fit prediction line, wherein when this for that particular point at x-axis intersects with that line, the best fit line, the corresponding y-axis, the corresponding point at the y-axis will be the house price. We not only have linear regression, but we have an exponential regression best fit prediction model, wherein we don't have a straight line here. Instead, we have an exponential curve, and that also gives an answer, but the answer might be slightly different or might vary than that done here. So out of these, which is the best model? How can we choose which is the best model and which is very precise and accurate, so that we can decide that for 40 square meters the price is going to be this much? That depends on the cost function. Now let's have a look at a cost function and what a cost function is and how it affects in deciding which is the best fit model. What is our aim now? Our aim is to find the minimum cost function so that we get the best fit prediction. So how do we do that? To minimize difference between the predicted and the actual values. These are our actual values, the circles, and this is our predicted value. Basically, we cannot call it, it's nothing but the linear best fit line, linear regression best fit prediction line. But these values, when they are projected downwards along the y-axis to meet the best fit line that we assume to be, or upwards, these are our assumptions, are the predicted values. So hence, these are the actual values and this is my predicted value, and the difference between the prediction and actual value, the sum of the difference between the prediction and actual value will be the cost function. Similarly, it is the cost function defined for an exponential for an exponential model. It might be a slightly different. The values might be slightly different when compared to that of the linear model. In this case, again, we project it downwards. These are the actual values that we have got, and these are the predicted ones that we have. And so basically, cost function can be defined as the sum of the differences between the actual value and the predicted value. Why are we squaring this? It may so happen sometimes that the actual value may be different than the predicted value, or vice versa. Hence, to remove the chances of any negativity in the value of that particular component, we take the power of it. For further discussion, we continue with linear regression. Linear regression is nothing but a straight line. The equation for a straight line is equal to y is equal to mx plus c. Here y is equal to wxb, where w stands for the weight and b for the nothing but the intersect. W is nothing but the gradient or the slope of a given line. We can tweak the value of w and b in order to get the best fit. So again, there are two ways of choosing or tweaking the value of w and b. Obviously, there is one way that we all can think of, is random method. The second one is the gradient descent method. The random method, we can never know that it can be again leading us into an infinite solution, because you never know where the solution is heading to or where the value of w is heading to, because it may again become an infinite thing that we can it's as good as not having done that previously and having to do it again. If you have already computed that previous value, and again there are all the chances that you may revisit the same value or the same slope. So hence we always go for the gradient descent method, where that it takes us to the direction where the steepness is greater, so that we might get the best fit for our current model. And hence we repeat this iteratively until we get close or converge for the good values of in order to get good values of w and b. Okay, now let's see the TensorFlow model. We'll go through the basics first and implement these basics to get to solve the problem. So first we have to find the equation for the line, that is y is equal to mx plus c, or y is equal to wx plus b in this particular case. So x will be the data which we will store. So what is tf dot placeholder? It holds all the data that need to be fed into the model. Okay, so x value will be TF stands for TensorFlow because we import TensorFlow as TF in Python, as we already saw in the example problem. So it stays TF stands for TensorFlow dot placeholder TF float 32. This is the data type, and this is optional, and this gives the size of the house that we can see, but this is completely optional for depending on the problem set and depending on the scenario. This particular second parameter is optional. Let's dive deeper into this and just check how should we go about it. Okay, so this is how a tf.placeholder looks like. The syntax for it is tf.placeholder, data type, shape, and name. And so basically inserts a plate for the tensor that will be fed, and this won't run independently. It has to be fed into session.run, as you already spoke about it earlier, that anything that happens anything that's actually running, that's because of session.run. Until then, there you cannot run the program. Okay, so we again take an example. X is equal to tf.placeholder. This is the data type, this is shape, and this shape actually can be anything. It can be Python. In Python, it can be lists, tuples, etc. And this is like the session. This we'll talk about later. Let's have a look at the arguments. D type is the data type, the type of elements in the tensor to be fed. The shape of the tensor to be fed, that is optional. If shape is not specified, you can feed a tensor of any shape. Name, the name for that operation is optional again. What does it return? A tensor. Tensor, what do you mean by tensor? A multi-dimensional or n-dimensional array. So it returns that a tensor that may be used as a handle for feeding a value but not evaluated directly. So we'll exactly see what the tensor shape looks like and what it is. So it's a class. So it represents the shape of a tensor. The tensor type represents a possibly partial shape specification for a tensor. It may be one of the following. It's like you may have a fully known shape, partially known shape, and unknown shape. So fully known shape, it's like predefined, has a known number of dimensions and a known size for each dimension. So you basically know all the details about that particular shape. If you just for example, that it's like a 3x3 matrix, or it gets like 3x3x3 matrix, and you know that it's going to be like 3x3x3 only and nothing other than that. So if it's definitive and it's it's like predefined, and you know that that this is going to be my value of the dimension value, so you can go for fully known shape. If you know it partially, so you can go for partially known shape. And unknown shape, as you never know, maybe that might be the output of something that you might want to again filter it out. So unknown shape has an unknown number of dimensions and an unknown size in all dimensions. Okay, so moving back to our presentation. Yes, so what is tf dot variable? Basically here again recalling that y is equal to mx plus c, or y is equal to wx plus b. In this case, w and b are the variables that we have to determine in order the best fit values for, or the good values, or the so-called good values here in this case, in order to get our good values for w and b. So it basically what tf dot variable does is holds the variable that needs to be trained. So our w and b have to be trained in order to converge into a precise or an accurate value. So let's see in our case. So again we have a tf dot variable. TF stands for TensorFlow. So tf dot variable is tf dot 0. Basically you fill it with all zeros. Okay. See, similarly the second initially fill the whole variable with all zeros. So this is what it means. And the next slide would, and this is pretty simple. Tf dot matmul is nothing but the matrix multiplication. You're just trying to multiply x with w, because it's y is equal to mx plus wx plus b, so wx need to be multiplied. So it just states multiplying two matrices in inbuilt function in TensorFlow. So the product will be tf dot matrix multiplication of x comma w, and then you need to add that product into the intercept b here. So that is nothing but y is equal to tf dot multmax x comma w plus b. So now we got our equation to be working. So now let's see the next part. Yeah, so how do you get the best fit? As we already saw that we need to minimize the cost function. So there is nothing but the actual values or the recorded values. That tf dot placeholder, we already saw that all the data that needs to be fed into the model has to go inside placeholder. So we are doing the same here. So it's y underscore will have tf dot placeholder of the float value type and the house output. Then that means it will have one output, and so we need to minimize the cost function here. That's what we're doing here. So what we do is reduce the sum. Basically is like sigma of tf dot power of y minus y. So this is nothing but y minus sigma of y minus y underscore minus y whole square. So reduce sum basically is nothing but sigma of here, and power is nothing but the math dot, similar to the math dot power function in the above case. Okay, since we don't have any defined data as of now with us, so we just taking some random data. So we just created like using this Python loop here. So for I in range till 100, so it from 0 to 100 it ranges, so 0 to 99 you get it because it's exclusive in the end. So you have 0 to 99. So xs, so the around the x-axis that you create an array. So you say just like np dot array of I, and similarly y of s is np dot array of 2 times of I. So this is some random bogus data which we get. So xs will give you this much is what we see here I, and ys is going to give you till 98 because you're doubling it. So yes, sorry about it. Yeah. So again y is equal to wx plus b, where w is equal to 2 and b is equal to 0. So what is the cost function? What is the function? If you just can observe, it's all about observation. Though we have created the same data, even in real world you have to create a function. Though we have taken a simpler function which we can actually get to know the moment we see the data here, but there has to be a function that relates between y and x. So in this case it is the best fit function is equal to y is equal to 2, y is equal to 2x, and so that's how we get y is equal to wx plus vb. That's how we populate it. Yeah, but which training model do we actually use? As we already spoke about it in the earlier slides, that we can either go for random or we can either go for the gradient descent method to train it. So now we train it in, obviously you have basically what gradient descent does is it from the current viewpoint it goes towards the direction where the steep is high, okay, where it's more steeper. That's what it does. So it does, and whereas the steepness there is more steepness, and you descend it with the steps of 0.000001. So there's an inbuilt function again in TensorFlow. So it's just train underscore step will give you tf.train. You try training it. There's a training model that you try choosing. So that will be the gradient descent optimizer is the model name. So in what steps is 0.00001 dot minimize the cost function. This is what this is how you train the data. And now we move on to the training model. Exactly how you train that model. So we in TensorFlow there is something called SESS is a variable there. So tf.session is when the session gets created. This is after this is where we try creating all the data flow graphs and all those things. In that case the graphs are just created after the session. So it is just like an init function. We can just say for an example that it looks very similar and works very similar to an init function because the graphs are initiated that time and they are constructed, and init what it does is initializes all the variables. Okay, I was just talking about the function where with regard to the graph creation, and this init is where you initialize all the variables. Okay, So session run is where everything happens. Without session run, only the it's like you can till session dot run is executed, everything is static. There's nothing happening until and unless you actually execute session dot run as the on all the variables that is defined in inet. So we do it for like what 100 iterations, and so that we can so that and hopefully converge to precise and accurate values, or good so-called good values of w and b. So let's have a look at that. Really, I'm using 2.7. Okay, so just let's recheck whether TensorFlow is working. Waiting. Okay. Yeah, so it works. So okay, now let's implement the program. File something .python, let's just say TensorFlow test.py. Okay, so say first we need to import. So we say import, we also will be using part of numpy, so numpy library will be importing as numpy. Then import TensorFlow as tf. Then you have to model the linear regression, y is equal to wx plus b. So let's model the linear regression. So that will be, so we have x will give you tf dot placeholder of what, so you have tf dot float 32 data type. Then you have, that means you have the one output is like 1. So now we have w will give you tf dot, just check whether this works, variable. So you have tf dot zeros, because you need to fill it with zeros. So we have b is equal to variable, again tf dot here, so it has to be 1 of this, and it needs to be that. Okay, so yeah, array of array. So now we will take the product. So product is nothing but tf dot matrix multiplication of w and x, so x comma w. So this will give us the product, and let's take the y actual values, that's product plus y values, predicted values, and let's have the y actual values, the values that we'll be taking in as this will be the predicted values, and this will be our actual values. Okay, So that will be again tf dot placeholder, tf dot float 32. They have so what we do next, now we have got w is equal to mx plus c, so let's just comment it here. So w is equal to wx plus b, so we've got this here. And so the second one will be the cost function that we'll be making use of. This case, so we do cost will be equal to tf dot value sum, okay, of, so you take the power of, should be from 2 dot 2, so what you take, y underscore minus the actual. As I've already explained, why do we take the power of y minus y underscore minus y? Because sometimes the actual values and the predicted value, sometimes actual values might be greater than the predicted values, and vice versa. So that's the reason to remove all the negativity, the negative sign from there, and to always have a positive number, we square it. Okay, so we need to train it now, so we'll be using train step will be equal to tf dot train, so we make use of the gradient descent optimizer. Step is 0.0000001, so there are like 6 zeros here, so we try minimizing the cost here in this case. Okay, that's good. After that, now we try to create a session, so we just say tf dot session, and we initialize all the variables in this case. So init will be tf dot initialize all variables, so all the variables here get initialized. How do we know what all the variables is? Anything which starts with tf variable, tf dot variable, so w and b are the variables here, they get initialized now. And now it's time to run the session. This is when everything happens. Now we'll go with 100 iterations. Okay, so now we move on to write a simple for loop to run that, and we have to populate the data. So let's just populate it like this: array of different array, and so when it has ys is equal to an array, so I just do 2 into I. Okay, so then I train it, so I say feed it, we need to feed it, so we do something like this: x will be given as xs, and y underscore will be given as ys. Okay, so we've done this part already, so SESS css dot run will run I need to train. I have to run my train underscore step, and feed underscore dict will be nothing but the feed. So let's just run it, train underscore step. So we know that train underscore step is what, and feed underscore dict nothing but the feed. Okay. So now we'll just print for better visibility and better understanding. So we'll all print for after each iteration. We'll be printing the values of w and b. So we just say, print something, print something, print something. So we just say after the so and so iteration will be this. So let's say the value is nothing but the percentage I and the value of w will be so the value of w will be since it's a float, let's say percentage f, so percentage f and percentage essence dot run, that is going to run it with my variable here. So let's save some time. So I say wb and I run b. Yeah. So now we've written a function wherein we import numpy package as np and import TensorFlow as tf, and numpy is basically used for a lot of statistics. You can, if you want to know more about it, please check the documentation upon python.org website. So here we are trying to model linear regression. Y is equal to wx plus v is the straight line that is we are trying to fit in we have the best fitting line here, and we take in the cost function here by minimizing the in order to minimize the cost function. Basically we do this so that y minus y square and sigma of that. So and we use the gradient training method as the gradient descent optimizer with the step of 0.10 power minus 6 in this case, minus 7 sorry in this case, and minimize cost in this case. And here is when you initialize a session and you initialize all the variables and you run the session. So this will be steps is equal to 100. So we'll be iterating 100, and for I range is a simple for loop that is again written. For each time the loop is going to run, we will see how close or how the way the values converge. So let's have a look at these values. We already know the values for w and b. So let's see whether the values are right. So just say save it up. Oops, there is an error in the program, sorry about it. There were a couple of mistakes here. I hadn't written inet, so inet comes here, and so I need to initialize, you need to run all the variables, so I just install the inet, and hopefully the program should run now without any errors. Yeah, so bingo, it ran, and let's see. So this program started off with the 0th iteration. We already know what our expected values should be. You can see that using in the steps of 0.00001, this is where the gradient descent optimization comes into the picture. So w has to be close to 2 and b has to be close to 0. So this is in the 100 steps, and taking the way we have taken our gradient step to be. So we have achieved these values, and this is how close we could get. And if we want to get more and more precise answers, the precise values for W and B, so add more number of steps onto the for loop, or running for number of times, and this is how we go about executing a TensorFlow program, importing TensorFlow, creating a session, and initializing all the variables in the session, and then running it once for all. And this was a brief introduction to TensorFlow. Thank you for watching the video, and I hope you guys liked it.